Okay, I've been having some software issues, so I'm going to try and make this uh, into small chunks and do this in one take, so there may be mistakes in it. What I want you to do is to construct 3 portfolios using data from 8 stock. I think it's called 8 stocks or 8 stock portfolio on Desire to Learn. And also you'll use Farmer French data from that spreadsheet. The first thing we will do is construct 3 portfolios. We'll construct those portfolios using information from 2003 to 2007. We'll do a historical model, single index model, and then equally weighted model. We will allow short sales, and then we will repeat not allowing short sales. Then we'll do evaluation of the portfolio. We'll say, all right, here are the weights that we chose for our different portfolios. There'll be 5 of them. 2 historical, 2 single index, and 1 equally weighted. The 2 historicals, 1 allowing short sales, 1 not. Single index model allowing short sales and not, which should come out to be the same thing, but maybe not. So then we'll do the evaluation once we have those weights. We'll put those weights on in January 2008 and let the portfolio run through 2012. We'll do the Sharpe ratio, Trainer measure, Jensen's alpha, Farman French alpha. And then we will use the equally weighted index as the benchmark. We'll subtract the returns of historical, or we'll subtract the benchmark equally weighted from the historical returns and from the single index model returns, and then run the Farman French regression again. Okay, so just to start, we'll do insert pivot table, click OK. I want to do this with perm numbers rather than tickers, and put returns for values and the date in the row label. And this is a 1 just means there is a return. So if I go down here, I'll see that there's these run out. And what happens, this was AT&T that merged with, I believe it was South Central Bell. So those overlap, and turns out this perm number is for the company that's the smaller of the 2 that we don't want to deal with. So we'll get rid of those returns after we copy and paste. We'll get rid of these returns, delete this, call this a date, bold, underline, center. Let's go to view, freeze the top row. I want to get all of these numbers right here. I want to format those so it looks nice. I don't need this grand total anymore, so delete that. Page up, and what I want to assume in this little experiment that we're going to run, oops, I didn't mean to delete, I meant to insert. So insert a row, insert a row. All of this 2007 and prior is going to be historical data that we can use, so we know that. So I need to have my returns. So copy, paste right here. Let's call this returns. Put that S in there. Okay, now merge and center. This will be equal to the average. Press period, then control down. That takes me to where there's a break in the data. This all the way across. I might have right here, I'm just going to put RF for risk free, and let's make that 0.02 divided by 12. Oops. Plus 0.02 plus 0.02 divided by 12. To make it monthly, I need to have my covariance matrix. So go to data analysis, go to covariance, highlight all that. See, I've already done that because I had trouble with the software before. My output range, let's put that right here. Click OK. And now to do the calculations, I'll say, let me copy this over here. Copy that back, paste special, transpose skip blanks, do the values to help with the formatting, and go to home, go to number, then let me get rid of that, clear contents. Okay, so now I need to find the weights for all of this. So copy, paste. And the way I do the weights, it's going to be a 8x1 matrix. So multiply the matrix inverse of this times, I need to transpose, right, because this right here is a 1x8, I need an 8x1, so transpose all of this, subtract the risk-free rate, couple parentheses, Control-Shift-Enter. I'm not quite done. I need to divide all of this by the sum of what was in the numerator. So copy, paste. I know I need more parentheses. I think that's right. Get the numbers here. Alt equal, sum it up, and sums to 100%. Perfect. So now I have historical data, assuming I can have short sales. So I have historical data assuming no short sales. This is what I need to do. I'm going to start with, and I'll put this all in percent. I'll start with it equally weighted. I got to start somewhere. I see that this sums up. I need to have my Sharpe ratio. So in order to have this, and I want to maximize the Sharpe ratio, well, I need to have the returns, right? So the returns are equal to the weights. So matrix multiply. The weights are in an 8x1, the returns are in a 1x8. So I need to do the 1x8 with the 8x1. Close parenthesis, that's the returns, and then I need to subtract the risk-free rate. Control-Shift-Enter, and then I need to find the sigma. I find the sigma by multiplying the weights, which is an 8x1, so I need to have the transpose of the weights times the covariance matrix. If I do Control-Shift-Enter, yeah, that's still working. I got a number there, but I want to multiply that again. It's going to stop right here. Multiply this by the weights So that's the variance of that portfolio. I want this sigma, I want this square root. And there it is. So Sharpe is equal to the excess returns divided by the volatility. So now I want to maximize the Sharpe ratio. So I go to Data, Solver. I want to maximize, I want to take the Sharpe ratio here. Get this over here so you can see. I want to not minimize, not set to a value. I want to maximize it by changing these weights. But one rule about those weights, they all have to sum. There's a constraint. All these have to sum to 1. So make that equal to 1. Click OK. Click Solve. And look, it's given me the exact same weights. So I know this closed form solution really works, and by doing this I know I have everything set up right. But the one thing I didn't mention, well, there are no short sales, right? So I need a new constraint. So all of these have to be greater than or equal to 0. So add that So I've added that constraint, click solve, OK, and there is historical using short sales allowed, historical no short sales. Okay, so quickly with the single index model, this is when all we have to do is find a new set of returns. So to get the returns, we need to have an alpha, we need to have a beta, and we need to have a market risk premium. The alpha you just need to come up with yourself, so like 0.01, but make it monthly, so divide by 12. Make the rest of these 0, just to make it easy. The beta, I can find beta by saying slope of this period control down, comma, with the market, which I haven't got the market yet, so I need to go to my original data. These are the market returns to 2007. Let me put these, I'm going to put these right here for now. I'm going to insert this column. Now I can copy this back over. This is the market. Yep, got the right number in there. So I don't need this. So the beta is going to be equal to the slope the Y is your stock, period control down, comma, the market is X, period control up, go back down 1. Okay, I screwed up. There we go. And so when I lock this down, so F4, F4, I'm going to copy this across, and my market risk premium, say is 5%, but make it monthly, so 5 divided by 12. And I don't need this last column, that's just the market. Okay, so a couple things here about the beta estimation. What I really want to have is excess returns when I calculate beta. So it's going to be the returns from the stock minus the risk-free rate, returns of the market minus the risk-free rate. I don't have that data, so I can't do it. So this is going to be a best guess. So my overall returns are equal to alpha plus beta times the market risk premium plus, well, I still have the risk-free rate I need to put in there. So those are my monthly returns. And in order to get my covariance matrix, so I need this. Let me just copy it for the form. And clear that out. Everything on the diagonal is going to be the same. This is still going to be the same variance, so that's the same. That's the same, but what's going to be different is this is going to be equal to the beta of this times the beta of that times the variance of the market. And you can get the variance of the market this way. I'll just put it right here, equal to the variance of the market. So that's how you get the betas. I mean, excuse me, the covariances. Beta of that one times beta of that one times the variance of the market, and you know this is the same number. You just got to fill that out. Fill that out, and then we have the single index model. You can come up with the weights the exact same way that we found historical. We just have a new set of returns and a new covariance matrix. All right, hopefully this will